Alright, welcome back. In this video, we are going to make the door work. We're going to do project 5.1, control the door. This involves servos. Automatic doors and windows need power device, which will become more automatic with a 180-degree servo and some sensors. I don't understand that sentence very much. Adding a raindrop sensor, you can achieve the effect of closing windows automatically when raining. If adding an RFID, we can realize the effect of swiping to open the door, and so on. Component knowledge. A servo. Servo is a position servo driver device. Consists of a housing, a circuit board, a coreless motor, interesting, a gear, and a position detector. Its working principle is that the servo receives a signal sent by the MCU, the Marvel Cinematic Universe, or receiver, probably a master control, I don't know, or a receiver, and produces a reference signal with a period of 20 milliseconds and a pulse width of 1.5 milliseconds. And then compares the acquired DC bias voltage to the voltage of the potentiometer and obtain the voltage difference output. I'm going to have to read that about 3 or 4 more times to figure out exactly what that means. The IC, integrated circuit. The IC on the circuit board judges the direction of rotation and then drives the coreless motor to start rotation. The power is transmitted to the swing arm through the reduction gear, and the signal is sent back by the position detector to judge whether the position has been reached, which is suitable for those control systems that require constant angle change and can be maintained. When the motor speed is constant, the potentiometer is driven to rotate through the cascade reduction gear, which leads that the voltage difference is 0 and the motor stops rotating. Generally, the angle of a servo rotation is 0 to 180. That's just saying most of the time you get 180 degrees out of a servo. The pulse period of the control servo is 20 milliseconds. The pulse width is 0.5 milliseconds, around half a millisecond to 2.5 milliseconds rather. And the corresponding position is usually between negative 90 to positive 90. So that's how we get our 180 degrees. We have a 0 reference and we can go negative 90 all the way over to positive 90, which covers 180 degrees. So the input signal pulse width of a period of 20 milliseconds, this right here, would angle of the steering shaft output, and 1 millisecond is 45, 1.5 is 0, 2 milliseconds, and 2.5. So at each of these different pulse width periods, control whether we're far to the left, far to the right, or somewhere in the middle. In general, the servo has 3 lines in brown, red, and orange. The brown is grounded, and the red one is a positive pole, and the orange is signal line. So ground, positive, and then orange. I guess it's probably yellow. Yeah, pulse width modulation. So ground, voltage, and signal. And there's our servo. Okay, so we're going to wire the servo of the window goes to pin 5 and the servo of the door goes to pin 13. And we did all of this in the assembly videos, and unfortunately I did not record those. They're on my TikTok page, but I did not save them to put them on YouTube. I wasn't working on YouTube at the time. So those are buried somewhere in TikTok, the assembly for this whole device, but we're only doing the programming right now. So we have our test code. We'll go through that in a minute. And the test result, the servo of the door turns with the door back and forth. So that should be this little guy down here. And this is, it's like a revolving door, the way that it's set up to look and be. So that's our test result. That's what we're going for. Now I'm going to go, let's look at the code. First thing we're going to do is include this ESP servo.h. So let's go into our sketch. We want to include a library. We want to add a zip library. And I don't know if you can see all of this, but we want ESP servo. Nope, that's not right. Okay. Arduino. I don't think you can actually see the you can't see the page I'm working on right now because I've got it in the there it is. It's not showing up as a window on OBS, but that's okay. We did successfully install the library, as you see. So let's try and run it first and see what happens. And then we'll try and step through the code. Servo was not declared in this scope. Did you mean servo? Maybe. But what does it say? And what they're talking about is right here on line 17. This object right here. Let's take a quick look at the original code again. Something's not right. So that is lines. That's this right here. Oh, that is because this is part of the comment. There. And then these are continued comments down here. So that's what we get for not reading. It's mostly your fault, but okay, hang on. Let's go take another look at our code again. Let's stretch this out a little bit so we can see better. Okay, so we're going to include that library servo. We create a servo called myServo, right? And in fact, I'm going to run this again while I'm waiting because that should fix it. Create a servo object. So myServo is an object, right? To control the servo. 16 servo objects can be created on the ESP32. And you can hopefully, while I'm talking, let's take a quick look here. Let me, I'm not going to use that. Let me find something else to prop this up with. I was going to put my Bible under there, but I'm not going to do that. I'm not going to do that with my Bible. What I want to point out is you can see right down here that the door is moving. That's what we're caring about, right? That's our servo there. So that's showing us that our servo is working. Get down there. See if I can put a little light on there. There we go. And now you can see. So that's going on. So we can connect 16 servo objects. 16 servo objects can be created on the ESP32. So a servo object is code, right? We're creating a code object. It's a class of objects called servo, and this is an instantiation of the servo class, and we name this instantiation myServo. We could call it anything. We could call it, you Steve's servo. We can call it whatever. But we're creating and this is kind of a giveaway by the fact that it's capitalized, and also when we mouse over it, it tells us it's a class. So we create a class, we call it myServo, right? And now actually, you see all these functions, right? It's attached to that class. This would be a good use to call it a method, right? Because it's attached to a class. That method comes from a class. So anyway, we create an integer and we name it POS for position, and we instantiate that with the value of 0. So it's going to, when we build this, it's going to start in the middle, right? Because we said we had 90, negative 90, 0's in the middle. So this is going to start in the middle. And then we have an integer, and we call it servo pin, and that's number 13. Servo pin equals 13. But this is a number. This is a number. This can be a positive or a negative number or even 0. But here we want to we named it servo pin, and we assign it the value of 13. So it is an integer. Okay. Our setup is going to allow allocation of all timers. What does that mean? We'll figure that out. ESP32, pulse width modulation, allocate timer 1. ESP32, allocate timer 2, 3. myServo, set period hertz. Hertz is frequency. So we want that 50 hertz, standard 50 hertz servo. myServo, once again referring to our object that we created, servo pin. That's a type. It's got a value of 13, passed as pin. So pin 13. And what's this overload right here tell us? Well, I wonder if this is a typo. Attaches the servo to pin 18 on the servo object using default min and max of 1000 microseconds or 2000 microseconds. Different servos may require different min-max settings for an accurate 0 to 180 sweep. Okay. Still curious if that's a typo. It looks like it should be. Anyway, so that's our setup. Our setup is going to establish, I forget what this operator does here. But that's a class. And this is a static method within that class. So we talk about static methods are methods that are already written. So I'm not creating a new method from scratch. This is it's a function that exists inside this library that's attached to this class. And like we said in a previous video, if a function is attached to a class or an object, things like that, then we call it a method, right? So for example, every C# script, every Java script is a class. However, a JavaScript script, because Java and JavaScript are two completely different languages, a JavaScript document is not a class, but a Java document and a C# document, those scripts are classes. So everything within a Java document and everything within a C# document, every function would be called a method because they're inherently attached to the class. But if we were looking at JavaScript, JavaScript runs more like this, where we have this function right out here, and it's not attached to a class at all. This is a setup function. This script is not a class. This is just a bare script. I know it may not make a lot of sense to a lot of you. It might not. But that's the difference between a method and a function. So, like, technically, it is kind of a technicality. It's a little bit of being pedantic because a method is a type of function. But the difference is that the method is, like we saw before, right here. If we highlight this, we'll see. Oh, come on. Let's mouse over that thing. The static method is part of a class. A class has a lot of objects and methods in it. It can. So, anyway, this is establishing our class and our static method within that. We have my server, my servo, set period hertz, another, this is an instance method. So we instantiated my servo as an object. So this is an instance method. And we're just going over some terminology here, right? It's an instance method because we instantiated an object. We still call it a method. It's attached to an object. But it serves the same function as a function. You see, it's got a name, it's got the parentheses, it's got overloads. And when we call this, it's going to do something, but it's going to do something from an existing library. Okay, we're going to move on. We got our loop for if position equals 0, and then if the position is less than 180, we will increment it by 1. Increment position by 1. My servo write position tells the servo we're writing to the servo. All right. Keep that in mind. We could write to the console like we've done earlier to notice the change on the console. But also keep in mind, we're not returning any type. We're not returning an integer. We're not returning any value. We are simply taking this, okay, for. We declare this loop variable right here. We declare position equals 0. So we make a variable right there. And then after that, we say if this variable is less or equal to 180, then we increment this variable by 1. And it says it goes up from 0 degrees to 80 degrees in steps of 1 degree. And we are writing this number to the myServo position where we're taking this number, this value, and we're saying write this to the myServo object. That's one of the things about code is you kind of have to read it backwards. If you notice, we start on the right and we work our way back to the left quite a bit. We have a 15-second delay for the servo to reach the position, 15 milliseconds to allow the. And then we have another loop, and we declare. Now, if you notice, this variable POS right here and this variable POS right here are not interfering with each other. And why is that? That is because this instance of the POS variable is only existing in this scope, in this block right here. This POS is only working in here. You'll see it down here, but this is actually a different instantiation. This is another local variable, right? Now, if we had put POS way up here at the top, it could be a global variable, and all of these can, use it. But typically, in a lot of for loops, especially when you're looking, they'll say for I equals, and the I is the variable. What we're looking for here is to make a meaningful variable name. It's just that when we're working with for loops, many times they are designed to increment or decrement. So they'll just say for this variable that we want to increment, we'll just call it I, and we'll name it at 0. And then if it's less than or equal to, if it's greater than or equal to. But the thing to remember is this POS variable is different from this POS variable because this is scoped within this for loop, and this is scoped within this for loop. And if this for loop is running, this should have no effect on this one. And when this one's running, this should have no effect on this one. So that's pretty much what we're looking at right there. And as we see, it's just tooling along right there. So it's just going back and forth. So it's going to run this loop, and it's going to increment all the way up to here, and it's going to loop until it gets equal to 180. When it becomes, let's see, at a certain point, it's going to get to the point where it's not going to do anything anymore, right? So let's play with that. Excuse me. Oops, let's do this. Let's just block that out and let's just see what happens. And so it's still running. Okay, there's our code coming up. The door stopped moving. Looks like we're initialized, but we're, see? Then it springs back. Because what, position equals 0, right? We're in this loop up here, we're saying the position is going to equal 0, and from 0 we're going to work all, if it's 0, we're going to work up to 180 by incrementing one by one. We're going to write that each time here. And then what happens next? Well, if we were there, if the position equals 180, then we decrement it all the way back down to 0, right? So this is what we're doing. It's just snapping back instead. So let's uncomment and reload that, and we're just going to watch it again, how the operation just goes back to normal here in just a few minutes. Yeah, we're getting a little bit long on time for this one, so we're going to be, but we're almost done. You see now the operation's gone back to smooth. So there we go. That's our servo. That's how our door works. And we didn't include anything else in the code. I'm going to change this to I'm going to change that to a 3, because first off, that's just a comment and it won't affect anything, but I really think that that's a typo. It's supposed to be integer servo pin equals 13. Then my servo, and you see servo pin, that's a variable, so we're overloading that. So this is my servo attach 13, and then servo pin. I really want to figure out what these two do. It's not giving me any information on that. If I can highlight all of that. Oh, there it is. The parameters are integer pin number, integer minimum, and integer max. So our minimum is 1000 and our max is 2000. And so that's our instance method to attach that in the servo. Yeah. Okay. Well, there you go. So that's our servo, and we'll keep moving on, in the future. So we'll see you next video. Thanks for watching. Have a great day.